Here's our first problem of finding the volume of revolution using cylindrical shells. And here's our function f of x equals x squared. And we're going to look at the area underneath f of x equal x squared from 0 to 1. And we're going to revolve this about the y-axis. Now, when we look at one particular rectangle and rotate it about the y-axis, we can visualize that we get what we call a cylindrical shell. All right. Notice that the height of this rectangle, or the rectangle, is parallel to the y-axis as we rotate it. All right. When we use the method of discs, then the rectangle was perpendicular. If we rotated about the x-axis, the rectangle was perpendicular to the x-axis, creating a disc, sweeping out a disc. When it's parallel to the axis of rotation, we get a cylindrical shell, which is what we have here. All right, let's write down our formula for the volume. Okay, the volume is equal to 2 pi. And we have the integral from 0 to 1. And then we have x, f of x dx. So in our case, that's equal to x times f of x. That's x times f of x is x squared, so that would be x cubed. And now let's just integrate. And we get x to the fourth over 4. And we're integrating between 0 and 1. Substitute in 1, so we have 2 pi over 4. When we substitute in 0, we get 0, so that reduces to pi over 2. Okay, so that's our volume. Our next example of finding the volume of a solid revolution using cylindrical shells is going to be similar to our first example. We have f of x equal x squared. And this time, instead of spinning the area below and above the x-axis around the y-axis, we're going to spin this shaded area, the area above the curve, and below the line y equal 1. Okay, all right, so this is the line. This is the line y equal 1. Let's compare it to the previous picture. Okay, here we took the area under the curve and spun it about the y-axis. Here we're taking the area over the curve and spinning it about the y-axis. So again, we look at a representative rectangle that is going to be spun around, and that helps us. That always helps us in visualization and in figuring out which formula to use. All right, now the top of this rectangle is the line y equal 1. The bottom of this rectangle is f of x equal x squared, hits the curve f of x equal x squared. The thickness the base of the rectangle is dx. Okay, this little base over here is parallel, is in the x direction. Okay, so we still call it dx. All right, if we spin this around, if you picture spinning this red rectangle around, we still get a cylindrical shell, just like before. The difference is that the base does not sit on the x-axis. Okay, so the difference is in the calculation of the height of this shell. Okay, before, what was the height? Well, from here to here, that was f of x. Okay, and this distance here is x. When we spin around, the radius is x. All right, so let's just compare it to the situation over here. When we spin, the radius is still x. It's this height that changes. Okay, so what is the height? Well, the top, this rectangle hits y equal 1 on top, and it hits x squared on the bottom. So just subtract the top minus the bottom, and the height of the rectangle is 1 on top minus x squared on the bottom. All right, so we're going to just modify our formula a little bit. Let's write down what delta V is. That'll help us in our calculation. So the volume of this cylindrical shell is the circumference 2 pi x times this height, which is 1 minus x squared. So that's the volume of one shell, and we're going to sort of sum these up to get the total volume. So the total volume, we're integrating from 0 to 1. And let me multiply this out. X times 1 is x, and x times x squared is x cubed. So that would be 2 pi x times 1 minus x squared, and we're integrating from 0 to 1, so let's do that. Do the power rule, x squared over 2 minus x to the 4th over 4, and substitute in from 0 to 1. Okay, now what do we have? We have 2 pi 1/2 minus 1/4. When we substitute in 1, when we substitute in 0, we get 0. So that's 2 pi times 1/4, 2 pi over 4, or pi over 2. All right, what answer did we get previously when we rotated the bottom, what's underneath the curve, around the y-axis? What did we get? Oh, we also got pi over 2. Okay, so here we get pi over 2, and we compare it to the answer above, which is also pi over 2. And if we add up these two volumes, we should get the volume of this square rotated about the y-axis. So let's look at that for a second. If we add up the sum of the volumes, the first volume, the volume from example 1, plus the volume from example 2, well, let's see, it's pi over 2 plus pi over 2. And if we look at the two areas, this top area and the bottom area, this is the curve y equals x squared. And if we rotate both of them about the y-axis, we just get a solid cylinder. And what's the volume of this solid cylinder? Well, the volume of the bottom, that's pi r squared. In this case, r is 1, times the height, which is also 1. Okay, so the volume of this thing is equal to pi times 1 squared times the height 1, or pi. Now let's add up the two pieces. We had pi over 2 plus pi over 2, and that's equal to pi. Okay, so at least that makes sense.